discuss one of the important topic which is related to the electronics is the arc lamp. What is the arc lamp? Arc lamp is a type of electric bulb, and it is type of electric lamp that produces the light by creating the arc. When the energy is supplied to the electrodes, then the arc is produced. So arc lamp is defined as a type of electric lamp that produces light by creating an arc between the two electrodes when electrical energy is supplied. So arc lamp, it produces the light after producing the arc between the two electrodes when the energy is supplied to these electrodes. So when it was invented in 1800, it was invented by the Sir Humphrey Davy, and he used the carbon electrodes to produce the arc, and this arc was created in the air and was used in searchlights and the high intensity movie projectors. So arc lamp was discovered in 1800 and that produced the light, and that time that light was used for the searchlights and the high intensity movie projectors. Nowadays, this arc is converted into the gas discharge lamp and are widely used because they are more efficient than the carbon arc lamp. Now, they produce a light by creating an arc similar to the carbon arc lamps, but they use an inert gas between the electrodes. So similarly the arc lamp is a gas discharge lamp also, and they produce the arc, and this arc produced because of the inert gas in between the electrodes. Now these lamps are enclosed in a glass tube. It is a glass chamber and under the low pressure. The gas is put under the low pressure and the electrodes are enveloped in the glass tube, and the arc forms because the inert gas inside the chamber gets ionized, and that's why when it is ionized, then arc is produced. For example, if we take the lamp, as you have seen in your laboratories also, xenon lamp, mercury lamp, neon, krypton, mercury xenon arc lamps. There are lots of lamps which we use in the industrial as well as in the laboratory purposes. So nowadays we are having a gas inside a chamber which is having a two electrode, and arc is produced, and this is arc produced because of the gas ionized, and there are the other many types of arc chambers. Xenon arc chamber xenon arc lamps are the most widely used lamp in the laboratory as well as in the industry purpose, as well as in the characterization purposes and in the research also. So what is the working principle of arc lamp? How arc lamp works? As we know that we require the electrodes. So what are the basic condition to develop a arc lamp? First, we require the two electrodes. Number two, we require the inert gas, and we require the power supply. So in the carbon arc lamp, if we talk about a carbon arc lamp, the electrodes first touch in the air, causing a low voltage to create an arc. Then the electrodes are slowly separated. Now heating the electric current and maintaining the arc, this heating causes the carbon electrode tips to evaporate. Now the carbon vapor produces a highly luminous, high intensity light in the form of arc, and the light's color depends on the temperature, time and electrical characteristics. So you see on the screen, this is the arc lamp. You see one side there is a anode and cap, and another side there is a cathode and cap. One is anode and that is the cathode, and it is enveloped in a glass chamber. This is the one type of arc lamp. Now in the gas discharge lamp, the arc is produced in the space between the electrodes, and this is filled with the inert gas, and the space is filled with an inert gas. The arc is produced by the ionization of this particular gas because of the electric current passed through it. So the electrodes and the gas together are covered with a glass tube. When an electrodes are given the high voltage power supply, the atoms in the gas experienced an inconceivable electrical force, and it results in the splitting of the atoms into the free electrons and ion, and this work on the ionization process. What happened when the voltage is supplied, high power voltage is supplied, the atom in the gas experiences the electric force, and it results in the splitting of the atoms and the free electrons and the ions, and the ionization takes place, and this process is known as the ionization process. So the principle behind the gas discharge lamp or the arc lamp is the ionization process. Now these broken atoms or the free electrons and the ions move in the contrasting direction, and the two charges, free electrons and the ions, collapse with each other and also with the electrodes. As a result, energy is emitted in the form of the flash of the light, and this flash of light is called the arc. So that's why it is called the arc lamp. Now this is known as the formation of the arc and is done by the discharging process. So it is also known as the discharge lamp. So we can call it as a arc lamp, we can call it as a gas discharge lamp, or we call it as a discharge lamp. So the name of the arc lamp and the color of the light emitted will directly depend on the atomic structure of the inert gas that is filled inside the gas tube. So the typical temperature of the arc is over the 3000 degree centigrade to 5400 degree centigrade. So the color of the light emitted by the xenon arc lamp is the white, and it is similar to the natural daylight which is used widely in the laboratories. And from the neon arc lamp we get the red color. From the mercury lamp we get the bluish color, and the combination of the inert gas if we used, they give more even light spectrum in the wider range of the wavelength. Means if we take the combination of the inert gas, then we can get the wide range of the wavelength. So arc lamp are classified into the 4 types. Number 1 is the DC carbon arc lamp. Number 2 is the AC carbon arc lamp. Number 3 is the flame arc lamp. Number 4 is the magnetic arc lamp. If we talk about the DC carbon arc lamp, you see on the screen, this is figure 1 and figure 2 which represent the DC arc lamp, and there is mentioned the carbon electrode. Now you see there is inert gas in between. The construction of the DC carbon arc lamp is defined here. We are having a power supply, then we have the electrodes, then how we can get it. In this type of the carbon arc lamp, 2 carbon electrodes are used, and these 2 electrodes are placed touching to each other face to face, and DC supply to the voltage of the 40 to 60 volt is applied. When the electric current flows through the electrodes, they soon become incandescent, and due to the high resistance of the carbon, and now these electrodes are slightly separated, and so that a gap of 2 mm to 3 mm is formed, as we have seen in the figure 2. You see here that the gap is produced between these 2 electrodes. First these 2 electrodes are touched, now the gap is given 2 mm or 3 mm gap is given between these 2 electrodes, and consequently the arc is created between the electrodes in this gap, and the white light is produced. In this type of arc lamp, the transfer of the carbon particles from one electrode to the another electrode maintains the arc in the gap. Because of the transfer of the carbon particle, the positive electrode after some time becomes hollow and the negative electrodes become as a pointed pencil as shown in figure we have seen. Now you see, now the left hand right hand side we are having a pointed electrode. Now here the arc is produced. Now this is the type of arc lamp where we get the white light, and both the electrode of the DC carbon arc lamp burn out after some time. So the rate of burning of positive electrode is twice that of the negative electrode. So therefore the area of cross section of the positive electrode is made twice of the area of the negative electrode when we talk about the DC carbon arc lamp. Now next type of arc lamp is the AC carbon arc lamp. Now if we talk about the construction and working of AC carbon arc lamp, it is similar to the DC carbon arc lamp. In case of the AC carbon arc lamp, the burning of both the positive and negative electrode is same. Therefore, their area of cross section is same. Since the carbon of the electrode is consumed during the operation of the lamp, hence frequent adjustment for the gap between the electrode is required. In case of the large AC carbon arc lamp, an automatic device is provided for feeding the carbon into the arc. So the AC carbon arc lamp requires the AC voltage of about 40 volts for their operation when the arc length is in the millimeter. So the overall luminous efficiency of the typical AC carbon arc lamp is very low, about 12 lumens per watt. So in the AC carbon lamp, a series of inductors are used for stability of the arc. So in the AC carbon arc lamp, we use the inductors. The temperature of the positive carbon electrode is about 3500 degrees centigrade to the 4000 degrees centigrade, and the temperature of the negative carbon electrode is about 2500 degrees centigrade. Therefore, the percentage of production of light from an AC carbon arc lamp would be 85% of the light is produced by the positive carbon electrode and 10% of the light is produced by the negative carbon electrode, and 5% of light is produced by the air. That is the AC arc lamp, AC carbon arc lamp. Now next type of lamp is the flame arc lamp. You see on the screen that the flame arc lamp also operate on the same working principle as the carbon arc lamp do. So the construction of the flame type arc lamp is as follows. You see here there is a north and south pole defined here, and two electrodes are defined here, and we are having a battery, and again we have supplied the voltage through the battery. So the electrodes of the flame arc has the 5% to 50% fluoride, that is called the flame material, and 80% to 95% it is having the carbon. So the fluoride has a characteristics, that is it radiates light energy efficiently from a very highly heated arc stream. So the fluoride turns into the vapor along with the carbon, and these vapors generate a very high luminescence intensity light. So the luminescence efficiency of the flame arc lamp is about 8 lumens per watt. Another type of arc lamp is the magnetic arc lamp. The basic construction and working of the magnetic arc lamp remains the same as that of the carbon arc lamp. The only difference is that in case of the magnetic arc lamp, the positive electrode is made of the copper and the negative electrode is made of the magnetic oxide of iron. and similarly the gap produced between these two electrodes and the voltage supply, then the arc is produced in this type of the magnetic arc lamp. These are almost a similar lamp and the construction are different, but the working is the same. Now another type which is we are talking about, that it is a very important highly specialized type of lamp and highly used lamp, that is a gas discharge lamp, is the xenon lamp. So further we will discuss about the xenon arc lamp. The xenon arc lamp is a highly specialized type of the gas discharge lamp and an electric light that produces by passing electricity through the ionized xenon gas at the high pressure. That's why it is called a xenon arc lamp, because in the chamber ionized gas, the gas xenon gas is filled at a high pressure and ionization will takes place in the xenon lamp and the light is produced. It produces a bright white light to simulate sunlight, and with application in the it is used in the movie projectors as well as searchlight and specialized uses in the industry and research in the laboratories. This xenon lamp are used. For example, xenon arc lamp and the mercury lamps are the two most common lamp used in the wide field fluorescence microscope. So, in the research purposes, when we do the characterization of the materials or any solid, liquid or gases, then we use the xenon arc lamp, which is a replica, which is try to be the replica of the sunlight. Xenon lamps can be roughly divided into the three categories. One is the continuous output xenon short arc lamp. Second is the continuous output xenon long arc lamp, and third is the xenon flash lamp, which is usually considered separately. So, xenon arc lamp having the three types: continuous output xenon short arc lamp, continuous output xenon long arc lamp and xenon flash lamp. So, each consists of a fused quartz or other heat resistance glass arc tube with a tungsten material electrode at each end. Means in xenon lamp we use the tungsten metal electrodes, and the gas tube is first evacuated and then refilled with the xenon gas. Now for the xenon flash tube, a third trigger electrode usually surrounds the exterior of the arc tube. If we taking the xenon flash tube, then another third electrode is also used surrounded the exterior of the arc tube. So, the lifetime of the xenon arc lamp varies according to the design and the power consumption, with a major manufacturer quoting average lifetime ranging from 500 hours for the 7 kilowatt or the 1500 hours for the 1 kilowatt. So, it depends upon the construction and it depends upon the designing of the or the power consumption of the xenon lamp. So, interest in the xenon discharge was first invented by the P. Schwells in 1944, and following his discovered the near continuous spectrum and high color rendering white light. And owing to wartime limitations of the availability of the noble gas, a significant progress was not made until the dawn of the British Siemens Lamp Company. Then he published the research paper in 1949. This triggered intensive efforts at the German Osram company to further develop the technology as a replacement for the carbon arc into the cinema projectors. So, xenon lamp promised tremendous advantages of a more stable arc with the less flickers, and its non-consumable electrodes allowed long films to be shown without the interruptions. What is the construction of this type of lamp? All modern xenon arc lamps use a fused quartz envelope with the threaded tungsten electrodes. Fused quartz is only the economically feasible material currently available that can be withstand the high pressure having the 25 atmosphere and having a high temperature present in the operating lamp will the still being the optically clear. So, the thorium dopant in the electrodes greatly enhances their electron emission characteristics because the tungsten and quartz have the different coefficient of the thermal expansion. So, the tungsten electrodes are welded to the strip of the pure molybdenum metal or inward alloy, which are then melted into the quartz to form the envelope seal. So, thorium dopant used for the electrode in this type of lamp because of the very high power level. High power level involves large lamps are water cooled, and in those use a IMAX projectors, and the electrodes bodies are made from the solid invar and tipped with the threaded tungsten, and O-ring sealed the tube so that the necked electrodes do not contact with the water. In the low power applications, the electrodes are too cold for efficient electron emission and are not cooled. And in the high power applications, an additional water cooling circuit for each electrode is necessary. To reduce the cost, water circuits are often not separated and the water needs the deionized to make it electrically non-conductive, which lets the quartz or some laser media dissolve into the water. So, normally we are having the maximum efficiency. How we can get the xenon inside short arc lamp is maintained at extremely high pressure, which is up to the 30 atmospheric pressure, and it poses the safety concern if the lamp is dropped or broken while the service. The pieces of the lamp enveloped can be thrown at high speed. So, the xenon lamp are normally shipped in protective shielding. And another point is that it is in the lamp's age risk failure increases, so bulb being replaced are at a greatest risk of the explosion. So, it is removed very carefully so that the damage will be less. We will continue in the next lecture. Thank you very much.